The formation of ozone dates back several billion years, when the Earth was formed. Initially, there was no atmosphere. The Earth's surface was covered by water vapor, methane, carbon dioxide and ammonia released from a molten mass. Gradually, the ultraviolet rays of the sun broke up the water vapor to form hydrogen and oxygen. Hydrogen, being a lighter gas than oxygen, escaped. The high-energy ultraviolet rays of the sun reacted with other oxygen molecules to form ozone. Ozone is found in low concentrations throughout the Earth's atmosphere. However, about 90% of ozone is found in the lower portion of the stratosphere, where it forms the ozone layer. This layer is between 13 kilometers and 20 kilometers above the Earth's surface and varies geographically and seasonally. The thickness of the ozone layer is measured in Dobson units. Depending on the function of ozone, it is categorized as bad or good. In the troposphere, ozone is considered an air pollutant as it harms plants and animals, and it is thus known as bad ozone. While in the stratosphere, ozone acts as a protective covering and blocks about 95 to 99% of harmful ultraviolet rays from entering the Earth. Here it is referred to as good ozone. Unfortunately, various human activities have resulted in depletion of the protective ozone layer. Moreover, there has been an imbalance between production and degradation of ozone in the atmosphere. This degradation has occurred due to chlorofluorocarbons or CFCs, which are mainly used as refrigerants in air conditioners, refrigerators, and aerosol products. When CFCs are discharged into the atmosphere, they move up to reach the stratosphere and, being long-lived molecules, remain in their original state. In the stratosphere, CFCs react with ultraviolet rays, releasing chlorine atoms, which in turn degrades ozone-releasing molecular oxygen. These chlorine atoms function as catalysts only. Moreover, the continuous addition of CFCs results in further degradation of the ozone layer. Scientists discovered that the decrease of ozone in the upper atmosphere depends on latitude. Studies have shown that the decrease in ozone is strongest in regions over the South Pole, that is, the Antarctic region. This thinned ozone layer is called an ozone hole. Similarly, there is an ozone hole over the Arctic region, but over a smaller area. The thinning of the ozone layer has made it possible for ultraviolet rays to reach the Earth's surface. These rays are highly injurious to organisms as they break the chemical bonds in DNA and protein molecules. Moreover, prolonged exposure to ultraviolet rays has harmful effects on human beings. It causes aging of the skin, damage to skin cells, and various types of skin cancers. Moreover, if the cornea of the eye absorbs high doses of UVB radiations, it causes inflammation of the cornea, commonly known as snow blindness cataract. Prolonged exposure to these rays may also permanently damage the cornea. Realizing the harmful effects of CFCs on the depletion of the ozone layer, 31 nations signed the Montreal Protocol in 1987 to limit their production of CFCs. As of today, 196 nations have signed the protocol. Several other measures have been taken and protocols laid down, with separate roadmaps for developed and developing countries to ensure a reduction in the emission of CFCs and other ozone-depleting substances or ODS. We too can prevent and control the depletion of the ozone layer by avoiding the use of CFCs and other ODS.